Hello viewers on YouTube. In this video tutorial, we are going to pay attention to how to partially differentiate a multivariate function that consists of the product of two other multivariate functions. What am I saying next? Consider the function z of x, y that is equal to the product of f of x, y and g of x, y. Now z consists of the product of two other multivariate functions. How do we differentiate z partially with respect to any of the independent variables? So that is the main purpose of this video. So just like differentiation, there's also a rule which we call the product rule in partial differentiation. So it says that to differentiate a multivariate function that consists of two other functions, then taking the partial derivative of z with respect to x, that is simply equal to the first function f of x, y multiplied by the partial derivative of the second one with respect to x, that is g x, or g sub x, whichever the case might be, or depending on how you want to write it. This will be added to the second function g of x, y multiplied by the partial derivative of the first function with respect to x, that's the f x. I'll be grab that. Similarly, z sub y, which is the partial derivative of z with respect to y, almost the same as this, but the difference is that instead of partially differentiated with respect to x, respectively here, you will have it as y. So that will be the first function f of x, y multiplied by g y plus g of x, y multiplied by f y. So this is what the product rule of partial differentiation says in essence. So let's put this into good use. Example number 1. Consider z to be equal to the product of 3x plus 5 and 2x plus 6y. So how do we find the partial derivative of z with respect to x? To keep things straightforward for you, here's what I would recommend. First thing first, identify your f and your g. So if our f of x, y is equal to 3x plus 5, then our g of x, y would be equals to 2x plus 6y. And if that is the case, or having done that, then try finding f sub x. Likewise, f sub y. F sub x is simply equal to 3. When you differentiate this function partially with respect to x, then you have 3. 5 is a constant, and when we differentiate it, we have 0. When you differentiate 3x with respect to x, you have 3. Also, when you differentiate f partially with respect to y, you would have 0. There's no y term in this whole function. And remember, in the class of partial differentiation, when you are differentiating a multivariate function with respect to a certain independent variable, the other independent variable must be treated as a constant. Since we are differentiating f with respect to y, x and any other thing must be treated as a constant. And since this can be considered to be a constant, and the derivative of a constant is 0, it means f sub y will be 0. Perfect. Then what would be g of x, or g sub x to say? Well, this will be considered as a constant. It means g sub x will simply be equal to 2, and that will be equal to 2. And finally, g sub y will be equal to 6. because the derivative of 2x is 0 because it's now a constant, and the derivative of 6y is simply 6. Now, having gotten all this, we can now come back to z sub x. Remember, the formula says that take the first function f of x comma y and multiply with the derivative of the second one with respect to x, g sub x. Then add it to the product of the second function, g of x comma y, and the derivative of the first function with respect to x partially. Hence, we now have 2x, or that's 3x. 3x plus 5 multiplied by g sub x, that's simply 2. So we have 2 plus 2x plus 6y multiplied by f sub x, that's simply 3 times 3. Then simplifying to the list form, we have 2 multiplied by 3x plus 5 plus 3 multiplied by 2x, excuse me, 2x plus 6y. Should we expand? Let's expand. 2 times 3x is 6x plus 10 plus 6x plus 18y. Adding this up, we have 12x plus 18y plus 10. And this is z sub x. So that's how you can easily differentiate a multivariate function partially with respect to a particular independent variable when the multivariate function consists of the product of two other multivariate functions. So now, let's consider finding z sub y. So we can get rid of this. Well, I really don't need to get rid of everything entirely here. So we just need to get rid of this one. Instead of f sub x, it will now be f sub y. Instead of g sub x, it will now be g sub y. And this is no more z sub x, but z sub y. Perfect. So let me have that in red. So we have z sub y. Then we have g sub y and f sub y. Excellent. So let's have it in yellow. It now implies that our z sub y will now be equal to f of x comma y is still 3x plus 5 multiplied by g sub y, that's 6 over here. So we have 6 plus g of x comma y, that's 2x plus 6y. 2x plus 6y, then multiplied by f sub y is 0. Well, that implies that this would entirely become 0, and we have 6 times 3x plus 5 left over. Expanding the bracket, we have 18x plus 30 as our z sub y. Thus, we have our final answer to this problem. So guys, that's how you can easily differentiate a multivariate function that consists of the product of two other multivariate functions. Example number 2. Consider the function z, let me have that in white, that is equal to 5y squared x squared, the minus 4y all squared multiplied by 2x plus 7y cubed x squared. So feel free to pause the video and figure this question out yourself. So we are required to find z sub x and z sub y. Just like before we actually touch z sub x, let's denote our f of x comma y and g of x comma y. So we can now use that to find our f sub x and g sub x. If our f of x comma y is equal to 5y squared x squared, I have to put that in the bracket, 5y squared x squared minus 4y all squared, and our g of x comma y is equal to 2x plus 7y cubed x squared. Then what would be f sub x? Remember, f of x comma y is a function of a function in relation to multivariate function. So the techniques of differentiating partially the function f with respect to x, you have to use the generalized power function of partial differentiation. If you have never heard about that before, feel free to check the description of this video, as I have a video on that already. So basically, the concept says that we should bring the index to the front, then multiply with the whole function again, reduce the index by 1, and then multiply it with the partial derivative of the function with respect to the independent variable. Thus, we have 2 multiplied by 5y squared x squared minus 4y, or to the power of 2 minus 1. We are reducing it by 1, it's still 1. So we are multiplying it with the partial derivative of k, which is the partial derivative of what is here with respect to x. So that k, that x. So what is k? K is this inside function. So if k is equal to 5y squared x squared minus 4y, then what would be k sub x, which is the same as that k that x? Let me use a certain notation throughout so that you won't get lost. Then that k that x this time around will be equal. So we are differentiating this entire function partially with respect to x. This will be considered as a constant. So we have 2 times 5y squared times x. We reduce by 1, we have x. This is 0, it's gone. So that's simply 10y squared x. That's our that k that x. So instead of that k that x here, we would have this one. Thus, our f sub x, or let me get rid of this instead. I hope you are following. So I'm trying to get rid of this entirely. Well, I don't need to get rid of that all. Let me just get rid of this one. Okay. So instead of that, we can have times 10y squared x. Thus, we have our f sub x. F sub x will now be equals to 2 times 10, that's 20y squared x, multiplied by 5y squared x squared minus 4y. Perfect. So that's f sub x. Now, what about f sub y? To get our f sub y, the process is the same. Basically, we take this to the front, okay, multiply with the entire function, and then the end multiply with the k that y. So if this comes to the front, we have 2 multiplied by the whole function, 5y squared x squared minus 4y. Then we reduce it by 1, that's just 1. Then multiply by the k, like y. Remember, this is what k is. If you differentiate k with respect to y, let's do that because we have 2 y's. So since k is equal to 5y squared x squared minus 4y, then that k that y would be equals to, you are treating 5x squared as a constant. So you have 5x squared multiplied by, differentiate this one, that's 2y. Then minus the derivative of 4y is simply 4. So we have 10yx squared minus 4. So I'm flipping the position of y and x. It doesn't mean they are being connected with a product sign. So flipping the position doesn't mean anything. So this is our k that y. So instead of having k that y here, let's substitute this right here. So we're getting rid of this one. And thus we have 10x or 10yx squared minus 4. Perfect. I can see that. Let me do that again. Excellent. Now let's go back to g. We also need our g of x comma y. So what will be our perfect. So if our g of x comma y is equal to this, what will be g sub x? G sub x will simply be equal to Okay, let's differentiate g of x comma y partially with respect to x. Remember, this is 2x, so the derivative of 2x is equal to 2 plus, now 7y cubed will be treated as a constant. Okay, then we have 7y cubed multiplied by the derivative of x squared is simply 2x. So it means g sub x will simply be equal to 2 plus 2x times 7y squared. Well, that's just the same as 2 plus 14xy squared. So that's our g sub x. Now likewise, our g sub y will be equal to, so we are differentiating partially with respect to y. This will become 0 as there is no y term. And this thing can come, we are treating 7x squared as a constant. Thus, we have 3y squared multiplied by 7x squared. And that gives us 3 times 7, that's 21. So we have 21x squared y squared. And this is simply our g sub y. Now that we have g sub x, g sub y, f sub x, and f sub y respectively, we can now get our z sub x and z sub y. I hope you're following. So that's basically how you can actually differentiate a multivariate function that consists of two products of two that consists of the product of two other multivariate functions. So now remember, the formula says that z sub x is simply equal to f of x comma y multiplied by g sub x, then plus g of x comma y multiplied by f sub x. So thus, we cannot get our answer at this point. I'm out of space, where I can get rid of the question instead. Well, yeah, I can get rid of this anyway. Then I can adjust the position of this all the way upward a little bit, so I can have a few more steps to bring it in there. So this will simply be equal to, let me have it in red. Now f of x comma y is this, so we have in a bracket 5y squared x squared minus 4y all squared to be multiplied by, remember the formula g sub x, sorry. So g sub x, let me have that in yellow. G sub x is this one, 2 plus 14xy squared. So we have times 2, let's put that in a bracket, it's a binomial, times 2 plus 14xy squared. Xy squared. Okay, perfect. Now we are adding it plus g of x comma y. This is g of x comma y. So we have that in red in a bracket. So we have 2x plus 7y cubed x squared, then multiply by f sub x. Our f sub x is simply this, which is the same thing as this is what we have here. Alright, then we have that in yellow, multiply by 20x or 20y squared x, and again multiply by 5y squared x squared minus 4. 5y squared x squared minus 4 y minus 4y. Wow. So how we can calculate that? I just have that squeezed over there. Okay, excellent. Then there's going to be another bracket here to enclose everything in relation to this 20. So that's simply z sub x. Now on to z sub y. Now this can go at this point. We only need f sub y left. Perfect. Now g sub x can also go. Now to get z sub y, that simply equals to f of x comma y multiplied by g sub y plus g of x comma y multiplied by f sub y. Thus, that will be equal to f of x comma y. Let's see the y here. So we have 5x, let's put in the bracket, 5y squared x squared minus 4y all squared, okay, and multiply by g sub y is this one, 21. We can put on the bracket if you want, but since it's just a single expression, you can just leave it like that. 21x squared y squared, then plus g of x comma y. G of x comma y is this one, and we have it in bracket 2x plus 7y cubed x squared, then multiply by f sub y. Then f sub y is this long expression here, so that's simply 2 times 5y squared x squared minus 4y. This is minus, okay, then multiply by 10y squared x squared minus 4 again, minus 4. So that's f sub y. Well, we can't actually simplify any further except if you want to expand some of these brackets. And that's simply our final solution to z sub y. So guys, this is how you can easily use the product rule of partial differentiation to differentiate partially a certain multivariate function that consists of the product, what's this, of two other independent multivariate functions. So thanks for watching. See you in the next video. Bye for now. So this is the exercise I have for you. So feel free to share solutions with me via the comment section below. So consider the function z that is equal to the product of 3yx squared minus 2 all to the power of 3, then multiply by 2x plus 5y all to the power of 2. Feel free to share solutions with me once again via the comment section below. Thank you. Bye for now.